Hi everyone. Today we're going to work on 1.4 notes, which is about piecewise functions. We will learn how to graph a piecewise function and also how to write the equation of a piecewise function when we see the graph of that function. Piecewise functions are functions that behave differently based on their input x value. Like in different intervals, they adopt different little functions. For example, here we see a piecewise function which has three different pieces. One is this one, the other one is this point, and the other one is this line. So in order to write the equation for this function, we need to mention the intervals, x intervals, and the function for those x intervals. Like for example here, for all the x values which are less than 2, our function is y equal to x squared. So I'm going to write when x less than 2, f of x is equal to x squared. And notice that we have an open circle here. That's why we're not going to write less than or equal, just less than. Then when x is equal to 2, y equal to 6. So we're going to write when x equal to 2, f of x equal to 6. For all the values between 2 and 6, our function is y equal to 10 minus x. So we're going to write when x is between 2 and 6, f of x equal to 10 minus x. Notice that we have an open circle here, but a closed circle here. So here we need to write x less than or equal to 6. The next example is an equation of a piecewise function, and we're going to try graph this function over here. So let's work on the first piece, which is 2x plus 2. We know that this is a linear function. So I know I'm going to have a line here for the first piece. So we know that in order to graph a function, we need some points. In order to create the points, I'm going to use a table here. 2x plus 2 goes here. Okay, so in order to find the points, we're going to make a table, and on one side is x, the other one is actually y, or 2x plus 2. So we need to try some points for x, but what points should we use here? Keep in mind that these points should fit into the domain which is given in front of this equation. So for this case, all the x values that you need to use should be less than 1, with one exception rule, which is we always need to use the border number. Like this negative 1 is the border number, so we have to use this one, which is negative 1. And then if I plug negative 1 here into my function, it's 2 times negative 1, which is negative 2, plus 2 is 0. So when x is negative 1, y is 0. Then I'm going to try another number. I can use negative 3, for example, because it's less than negative 1. But I cannot use 2. I cannot use 0, because those numbers are greater than negative 1. So I try negative 3, which is 2 times negative 3, negative 6 plus 2, negative 4. We can try negative 4 also. It will be negative 8 plus 2, negative 6. So the points are 0 and negative 1, which is here, negative 3 and negative 4. Then we have negative 4 and negative 6, which is here. So my line is going to be this. I connect these lines. So this is the graph of this little function over here. But I need to address two different things, like the end sides of this line. What is happening at x equal to negative 1? We know that we don't have any equation here, equality here. It's just less than. So I need to use an open circle at this point. And then on the other side, because it's all the x values which are less than negative 1, that means it's continuing forever to the left side. So I'm going to use an arrow here on this. So this is my first graph. The second one, x squared minus 1, we know that this is a parabola which has been moved 1 down. So I know what I'm going to draw. I'm going to have a curve which is like a parabola. So let's try the numbers. Again, the numbers should fit into our domain, but always use the border numbers. So I'm going to start with the first border number here. X is negative 1. Then y will be negative 1 squared minus 1, which is 0. Another number, let's try 0. When x is 0, y is negative 1. When x is 1, x is again 0. And the last number that I'm going to try is 2, because it's a border number. I have to try the border numbers. So it's 2 squared minus 1, which is 3. So these are my points for the second graph. 0 and negative 1 is here. Then negative 1 and 0, 0 and negative 1 is this one. 1 and 0 is here. 2 and 3 is here. So I can connect these points with a curve which looks like a parabola, something like this. Then let's address the endpoints. At negative 1 we have a less than or equal sign, so I have to use a closed circle. So this circle which was open before, now is closed. I show it this way so you know that it was open, now it's closed. The other side also we have less than or equal, so we use a closed circle again. So this is my second one. The last one, radical x plus 2. This is a square root function which has been moved 2 to the left. So I know what I'm gonna draw here. Try the numbers. First of all, the border number, which is 2. So square root of 2 plus 2 is square root of 4, which is 2. Then I need to try my next number. The next number should be something greater than 2. You could use 3, 4, 5, whatever. I'm going to use 7 because it's giving me a round number. 7 plus 2 is 9. Square root of that is 3. So my points are 2 and 2, which is here. The other point is 7 and 3. Is this one. So this is my graph now. The endpoints. This point, this side is an arrow because it's all x values greater than 2, and the other one at 2 I have a closed circle, so it's going to be like this. So this is the graph of my function. This time we have a graph of a piecewise function, and we want to write the equation for that. As you notice, we have 3 different pieces, so I'm going to write f of x equal to, and then I open a long bracket. Then I start with the first one on the left. So we know this is a constant function. By looking at the graph, we can say this is a constant function, and it's y equal to something, and that's 3. So my equation should be like y equal to 3 or f of x equal to 3, but I don't need to write the left side because the left side is already written here. So I'm just going to write the right side of that, 3. So f of x equal to 3 when? So I need to write the domain here. I'm looking for the domain of this piece. As you notice, it's from negative infinity to negative 1. So it's all the x values which are less than 1. Since I have an open circle, I am not going to write an equation sign here. So that's the first piece. The second piece, as you see, is a parabola which has been moved up 1. So I know that the equation is x squared plus 1. So you need to be familiar with all the parent functions and their equation. Then it's going to be easier for you to write the equation of a piecewise function. Okay, the next thing is to write the domain of this function. Starts from negative 1. You see this is the beginning and this one is the end, ends at 2. So the x is between -1 and 2. I have a closed circle here, so I'm going to write an equation sign here, an open circle, so I leave this as it is. The third piece of the function is a linear function. We know that the equation for linear function looks like y equal to mx plus b. This is the general form, and m is the slope, which is rise over run. So I can easily find that. I consider 2 points here. Rise over run is -1 over 1, which is -1. So m is -1. Now I need to find the b, which is a y-intercept. Based on the slope that I have, I can move backward the same way to see where my function is going to meet the y-axis. Like if my function was supposed to continue from the other side, where would it meet the y-axis? And it was right here, which is 4. So that means the b value is 4. Is equal to 4. So I'm going to write y equal to -x, because that's my m, or slope, plus 4, which is the b value. So this is my function. Now the domain, what is my domain? Starts from 2 and it's continuing forever. Although I don't have an arrow here, but you can just imagine we have an arrow because it's just continuing. If it was closed circle, then we would say it's stopping at this point. So now this is all the x values which are greater than or equal to 2, because I have a closed circle. So this is the equation for this piecewise function. Now we are going to do the last part of our lesson, which is evaluating piecewise function. Like we are going to figure out what is f of -1, f of -2 for different x values, what is my y. So let's try with the first one, f of -4. This -4 is the x value. So I need to find the value of function for -4. But my function is a piecewise function. It has 3 different pieces. Which one should I use here? I'm going to use the one that has the same domain as x. Like I choose the domain that my x fits there. So -4, where does it fit? Is it less than -2? Yes, it's less than -2. So I'm going to use this function 3x for this one. So I use 3x and plug in -4 for x, which is -12. Then f of -2. What is f of -2? -2 fits in the second one because it's greater than or equal to -2. So I use x to the 3 for this one. It's -2 to the power of 3, which is -8. f of 0. 0 again fits here because it's between -2 and 3. So again, we're going to use x to the power of 3 for this one. 0 to 3 is 0. f of 3, where does 3 fit? It fits both here and here. Basically, this was just a typo. So let's just consider this one, all the x values which are greater than 3. So we can say it fits here. So again, 3 to the power of 3 fits here, 27, because we use x to the 3. And then f of 7, 7 is greater than 3, so we can use the last one here. f of 7 is just -3, because my y value for this last piece is just -3. So f of 7 is -3. We used this one for this value of x. So this was our function. I hope it was helpful for you, and have a great day.